Hello. So today we're going to be creating uh, a a projectile for to shoot at an enemy. So to start, you can create like a triangle. You can add and go sprites or 2D object, sprites, then triangle. Okay, so then we set it to enemy, and then we have the player to a tag, and then now we can go to the script. So the script will be over here. So already add it to your enemy. So then go to the code, and then we have in our point two function. Then we have to have a way to distinguish the angle. So to find the angle, so to do that, we're gonna have to create a vector 3 called dir for direction, and then player dot position minus transform dot position, and then you need transform of player, and then what this does is if you have a transform player, then you have like this, and then player, and you subtract this position, and then okay, that's done. And then what we need next is, so we have something that we can find our angle with, and then let's actually find our angle. So math a10, and then direction x, direction y, and direction x. And this is because what you see here is that if you were to run the code with, so to y over x is how you calculate the angle, change in y over change in x would give you that in this case, and then this would just change radians to degrees because we need degrees in this case. And then if you subtract 90, there's an offset in Unity that offsets the angle by 90 degrees. So if you take it away, then it's back to normal. So, and then after that, let's create a rigid body. So let's go to a public rigid body 2D. Public rigid body RB. And then let's go down here to back to our code. Then in our point 2 function, rigid body dot rotation equals to angle, and then normalize our direction. Okay. Why is it highlighted red? Okay, so we have, and then we have movement is equal to direction. So it's this exact code. It's you can't convert it to a quaternion. So then the angle, so there's something wrong with the angle, that is that you have to, so then if you movement equals to direction, so this is not a quaternion, which we have to fix. So let's continue on with the code and then fix it. Okay, so then void move object and then rigid body dot move position of a new vector 2. Our transform dot position and then after the transform dot position we have to add direction times speed times time dot delta time and then have it auto corrected. So this exact code. And then we have this direction. And then yeah, okay, so we have a direction and then we actually need a parameter. Vector 2 direction. So this code, for some reason it just auto-corrected in here, but that wasn't supposed to be there. So it's just this, and then fixed update. Oh, okay. So to fix the quaternion. Okay, so we have this. So no quaternion error because you just have to add these variables, the movement coordinate and the player coordinate, the speed and the rigid body, and then this adds, so it's like it adds the coordinates onto each other to move from point A to point B in this function move object, and then in the fixed update we would have move object with our movement, which is our starting, and then another function which would come after, void update, which would come our point 2. Okay, this is for our code. So we have a vector 2. When you subtract it, you get this direction with a y coordinate and an x coordinate. Like if you have the point 0, 0 and 0, 1, the change in y is 1, the change in x is 0. So you couldn't so that's how it would calculate it. Like the point 5, 5, let's say, if we had the point 5, 5 and 10, 10, it would just plug into this code. So the direction is if you subtract 10, 10 minus 5, 5, which would give you 5, 5, which is 5 and 5 would go into this function. And yeah, so it would just be 1. Okay. So then we can go in here. Enemy code. Okay. So rigid body, let's add a rigid body. Make sure to do rigid body 2D. And then a gravity scale. Make sure to turn the gravity scale off so there's no gravity. And speed, let's do 2. Let's do 10. And then here we go. And let's see if what happened. And then let's see. Okay, so it loads up. Okay. Okay, yeah, okay. So we have to add the player's transform, which we have to put in the code. Oh, okay. It has to be public here. So you can access the player. Here we go. Okay, so here we added the player. So let's see what happens. Okay, now you see it's following it, and you clearly see it went way too fast. So let's just set it to like 0.5, and see it's going at you. So you see it's pointing in the right direction. I move up, it's pointing exactly to it and moving. And so you see it's up here, and it's saying that these 2 points are pointed in this direction. So let's see what happens when I show you guys that I don't have this minus 90 here. It doesn't, it has an offset, so it doesn't look as accurate. So it's not pointed in the right direction. If you see, it's a little off. So you're going to have to subtract 90 there. Subtract from 90 degrees. So, and then you could really do, you could have this, like, in red for, like, a missile, or so you see that it calculates the angle. So you see that this calculates the angle. So, and then it sets this to the movement. So you're moving in the correct direction, just like what this does. And then this basically makes it so you can move there. Yeah. So as you can see here, it works.